My name is Dr. Mallikarjun, currently working in Institute of Aeronautical Engineering in the Department of Information Technology as a professor in the series of video lectures of operating systems. Today, I am going to explain about the virtual memory. Virtual memory is a storage scheme that user feels as an illusion of having a big main memory. Actually, primary memory and secondary memory, this virtual memory creates the illusion, means that it expands more the capacity with the size of the main memory. So this is done by treating part of secondary memory as that main memory. This scheme, user can load the bigger size process than the available main memory by having the illusion that the memory is available load to that process. Instead of loading one big process in the main memory, the operating system loads the different parts of more than one process in the main memory. By doing this, the degree of multi-programming will increase. Means virtual memory performs as well. It increases the degree of multi-programming, increase the utilization of the CPU is more. It increases the CPU utilization and also increase the CPU performance and throughput. Everything depends on that virtual memory. See, virtual memory is a memory management technique that provides the illusion of a larger memory space than the actual RAM available in a computer. It allows the computer to run more programs or larger programs than would be possible with just the physical RAM by temporarily storing inactive data on the hard drive as a secondary storage disk. The stored data then be swapped back into RAM when needed, enabling the system to continue operating efficiently performs through this virtual memory. Actually, there is a secondary memory and then that is a primary memory are two different. Then operating system is loaded to the secondary memory to primary memory. In between that, the program size is larger than the execution size. There is a program size. There is a program. This program is larger than the main primary memory. Then it utilizes the capacity of the virtual memory. It expands and take that program and expands that memory and then execute that program in the main memory. So this is called that virtual memory as that capacity of the program size and increase the while execution of that program. It expands that memory. So that's illusion. It creates some memory and it creates that part of that memory illusion and execute that program in the CPU, in the memory part. That is called virtual memory. The RAM physical available on computer, it expands. Actually, in the CPU, memory is the important and crucial part. So that is a primary memory and secondary memory, and two are processing into the CPU. So the secondary memory to primary memory and primary memory to secondary memory, the information keeps on transfer. So this is performing through the demand paging. That is coming my next slide. I am explaining in detail about the demand paging. So that main memory is divided into different partitions. That is called frames. Main memory means primary memory or main memory, both are same. Or both we called as the same. Sometimes we called as the primary memory. Sometimes we called as the main memory. You would divide into different partitions. These partitions are called frame. that is frame 1, frame 2 and so on, n number of frames. I'm going to divide the main memory. In the secondary memory also, I'm going to divide the secondary memory to different partitions. These partitions are I can represent as the pages. Page 0, page 1, page 2, so on, n number of pages. That is in hard disk or secondary storage devices. So the different partitions performed through the main memory is called frames. Different partitions performed in the secondary memory is called the pages. So this is why this main memory, this is RAM, nothing but a RAM. I'm going to divide the RAM into different partitions. This is called frames. In the secondary memory, I'm going to divide the different partitions. This is called pages. Let me discuss in detail about the frames and pages from to the memory segmentation, paging, translation, virtual address space. I'm going to discuss about it in detail. That memory segmentation, the computer's memory is divided into small fixed size blocks. These called pages and segmentation. The secondary memory, I'm going to divide into fixed size blocks. The codings are these called segments. Actually, segmentation is different and paging is different. So small equal parts, paging is equal parts. Paging is pages is equal parts, but segmentation is not equal parts. Segmentation is different partitions. That is comes under the segmentation. Like module wise differentiation. That is called segmentation. Okay, paging, when a program needs more memory than the available in RAM, the operating systems moves swap some of the least recently used pages from RAM and hard drive. The least recently used pages can be transferred. This is called paging. The freeing space in the RAM for the other data. Some pages are become the free. So that is a pages. When the frame is free, then we can replace that page to the appropriate page from the main memory. This is called page replacement. That we will discuss later. Then we will go from translation. When a program needs to access the data that's between the swapped out and swapped in the operating system, that is the translation of the virtual address. The address used by the program to the physical address. The actual location on the hard drive address is called the physical address. The actual address used by the program is called the virtual address. That is two that already I discussed, the logical address and virtual address. Virtual address used by the program, actual address used by the program in the memory, that is called the virtual address. The actual location of that hard drive, the actual location where the address is located in the hard drive, that address is called the physical address. Virtual address space, each process gets its own virtual address space, meaning that program don't directly access the physical memory, they access on their own virtual memory, which is managed by the operating system. That's own accessing the address space from the accessing that virtual address space and directly accessing and directly their own virtual space, that is mentioned as the virtual address space, which is managed by the operating system. Okay, then that advantages of this virtual memory, mainly advantages, it increase the memory capacity, allows running more programs, larger programs than physical RAM, and would permit that it almost increase the capacity of the virtual memory. And what is the use of this virtual memory means? It's mainly performing through the multitasking. More number of processes executing at a time is called multitasking. Enables efficient execution of multi-programs simultaneously executing in the primary memory and secondary memory. In between that is called multitasking. And performing through the memory protection, it separates the address space of different process and preventing them from interfering with each others of the data, and that performs requires that protection requires. It separates that address space from different processors. And cost effectiveness reduce the need of expensive high capacity of that random access memory, utilization of the CPU and accessing of the pages and frames automatically, the effectiveness increases. All these are the advantages of the virtual memory. So increasing memory capacity, multitasking, memory protection, cost effectiveness, these are the primary factors of the virtual memory. Actually, virtual memory performs through the demand paging. That pages can be swapped from secondary memory to primary memory, and again primary memory to secondary memory. It performs through the demand paging. Demand paging is a popular method of the virtual memory management. In demand paging, the pages of process which are least used get stored in the secondary memory. So see the secondary memory part, there is a hard disk. I am going to divide into several number of parts. These are pages 1, page 2 and so on, page 3. These are n number of pages going to divide in the secondary memory. So a page is copied to the main memory. Actually, this is the main memory. The pages is copied to main memory. When demand is made, when the demand means when the page is required, suppose page 1 is required, then it is transfer. Page 4 is going to be transfer here, page 4. When the demand is required, the page can be replaced based on the demand. That is called swapped out. And again, it is the pages is required from secondary memory. This is swap out, and again the page is required from main memory to secondary memory. This is called swap in. Suppose page 5, page 6, page 7, suppose page 8 is required from the secondary memory. This performs through the swap in. The two operation out and in, that is out operation performing through the main memory to secondary memory. It performing through the out operation from secondary memory to main memory in out operation. So these are various page replacement algorithms which are used to determine which page will be replaced. That's page replacement algorithms are first in, first out, shortest job first, least recently used. These are various page replacement algorithms that we are going to be discussed in detail in my coming lectures. Okay, this actually page replacement algorithms, everything comes under to the a memory allocation. This is contiguous memory allocation and fixed size partitions and variable size partition. The memory can be divided either in a fixed size partition or the variable size partition in order to allocate a contiguous space in the user processes. Contiguous space can be fixed size, can be divided into partitions, paging and framing. These all comes under fixed size partitions. Variable size partitions comes under segmentation, internal fragmentation, external fragmentation. Those who are already discussed about that, internal fragmentation, external fragmentation, and now we are discussing about in detail about the virtual memory. Virtual memory runs through the technique of paging. That paging can be processed through work under the demand paging. Mainly the page is replaced from the secondary memory to main memory and main memory to secondary memory, that performing through the demand paging. Actually, So a complete picture of the demand paging when the page required that is swapped out, and the page is required from main memory that is swapped in. Thus two techniques performing to the demand paging. So this is a rectangular shape showing secondary memory, and that main memory is a left side. I'm showing left side, I'm showing main memory or physical memory, right side showing secondary memory. If the page is required, the tag taking place from swap out and swap in. Virtual memory performing through the demand paging technique completely. The what is the technique behind that virtual memory means? There is a demand paging. So the in detail discussion of the demand paging actually is that essential work of the demand paging is a virtual memory part is a crucial feature that allows modern computers to handle complex tasks and manage memory efficiently by creating larger and virtualized memory space beyond that physical memory RAM limit. So it is a part of that RAM comes under virtual memory. Finally, that virtual memory address space here, zero address, 4K, 8K of size, 12K and 16K of virtual address. A, B, C, D, E are there in the frames. The physical memory are there. These are the frame physical address as frames. Frame 1, frame 2, frame 3, frame 4, so on. There is a two pages in the secondary memory pages. There is a D page, page 1 and page 2 are there in the secondary memory, D and E. These two pages are those address are 12K and E address is 16K. That is the virtual address. In the secondary memory, there are two pages D and E. Those address called virtual address. That address is 12K and 16K as the virtual address. So these pages can be transferred to the physical memory. 12K and 16K has been transferred into the physical address space in the physical memory that is called main memory. That pages are transferred. So this is the how the pages are transferred through the address. That address is the virtual address and then pointing that virtual address to the physical address. The corresponding frame can be transferred from the secondary memory to physical memory as per this procedure. So this is completely as the demand paging technique performed internal addresses, virtual address and physical address. Actually, this is that virtual memory. There is a virtual memory table, is there memory table and physical memory. There is a memory map table in between that. That is map the virtual address to the physical address. That is the main performing of that mapping table. That's map the virtual address and physical address that map the memory mapping table that map the virtual address corresponding to the physical address. Then that is storage in the disk storage part. Each page and each frame that can be mapped to the virtual memory to the physical memory in the memory mapping technique that performing in the disk storage place. Each frame is allocated to the each page that's performed in the disk storage. That memory mapping can be performing through the divided two parts actually. That's one part is that virtual address is corresponding to map that address to the physical address. So then only the virtual pages can be mapping to the wherever it is free that place the page can be mapped. So this can be process can be involved to the completely in the detailed discussion of this virtual memory. So finally, the secondary memory that page can be loaded. Actually, the page table when some processes are not in the main memory, that page table having valid and invalid. Page number is present in the main memory that is called valid bit. Page number does not present in the memory that is called invalid bit. There is a process here 0, 1, 2, 3, their address, process A, process B, process C, and process D, then performing through the page map table, process 2 and 5, that is a valid bit and valid bit 2 and 5 valid bit. Then main memory or physical memory, the performing A and to the map to correspondingly 2 and C is correspondingly mapped with 5, then main memory or physical memory is mapping to the corresponding frames like A, B, C and D are loaded in the secondary memory. This complete map page table, when some process are not there in the main memory, that is called invalid bit. If the process is valid, that is table that can be mapped to the page map table, that can be stored in the page table, and that can be stored in the main memory, and that can be stored in secondary memory also. That is a valid bit. Okay, students, finally, I am going to concluding that if that is a process consists of the 4 pages. That is, those are A, B, C, D. So, A, B, C, D pages of a process is available in the secondary memory. Along with these process pages, A, B, C, D, other process may also available in the secondary memory. So, when CPU needs to execute a page, then it checks whether the page is available in the main memory or not. It checks. Then, if the page is available in the main memory, then no problem. The CPU execute that page. If the page is not available in the main memory, then it is called that page fault. When the page is available in the memory, there is no problem. That page is executing. When page fault occurs, some steps needed to perform about that. That is, we are going to discuss about it completely in the page replacement algorithms that I am going to give one more video. In that video, I am going to completely give the what is page fault, what is page hit, what is page miss. I am going to give the complete detail about my coming video. Okay, students, this material I gathered from the 2 reference books. That book is Abraham Silver Scratch Peter B. Galvin Ganji book by Operating System Principles is the title of the book, Wiley edition, 8th edition 2020. And then second book, William Stallings author, Operating System Internal and Design Principles, Pearson Education, 6th edition 2002. Okay, students, in this video, we given completely detail of the virtual memory concept and virtual memory management technique in detail about this video. Thank you, students.
Like, share and subscribe. Hit the bell icon for more updates.